We had mentioned that there are two types of sequences that we're going to discuss, arithmetic and geometric. In this video, we're going to talk about geometric sequences. A geometric sequence is a sequence, a sequence where each term can be found from the previous term by multiplying by the same non-zero constant. We call this non-zero constant this non-zero constant our common ratio, and our common ratio is going to be called r, little r. Why do we use ratio? Well, ratio, if you remember back to algebra, it can be written in a couple different ways. A ratio can be written as 1 to 2, or a ratio can be written as 1 to 2. Or the third way, which we will use it today and going forward with geometric sequences, is 1 to 2. So if we are talking about fractions and we're talking about multiplying by a non-zero constant, this is our trick. This is our mathematical trick that when we're saying we're going to multiply by some non-zero constant, that non-zero constant, that could be 1/2, that could be 2, that could be 7, it could be 2/3, it could be any of these things. But the trick in here is that when we are multiplying, if we multiply by a fraction, that's the same thing as saying dividing. That's the same action as dividing. So when we say we are multiplying by a number, in terms of geometric sequences, that means we're going to multiply or divide. And we're going to write our division as a fraction. All right, so that's the definition of what a geometric sequence is. And we want to try and figure out how can we come up with general equations, general formulas to get our sequence. So let's start by looking at a number pattern, a number sequence. We'll just kind of separate this off here. So we've got our pattern is going to be 2, 10, 50, 250, and so on. Now, you might have already figured out what this is because you're very astute, and so you're looking at that and saying, all right, I know what that is. And that is that we are going to multiply each thing by 5. Well, how do we figure that out mathematically? Well, we could say we just did it in our head, but that's not actually showing how we can do this mathematically. So what we can do is we can say, well, if I take 10 and I divide it by 2, so I've got 10 divided by 2, I'm going to get 5. Or I can just slide this thing right over here, and if I'm going to take 50 divided by 10, 50 divided by 10, I'm going to get 5. And I bet if we do the same thing one more time, if we take 250 and we divide it by 50, we are still going to get 5. So now we have our common ratio of 5. So therefore, this little symbol here, these little 3 dots, if you didn't know, that means therefore R equals 5. Our common ratio equals 5. And what you probably already figured out is we can do this as an equation too, just like we've done with other types of sequences. We could say, well, we took the next term and divided it by the previous term. And how did we write that? Well, before we wrote that as u of n plus 1, that's our next term, dividing it by our current term, or the previous term. And that's going to give us r. That's going to give us our common ratio. So in this case, this is the 4th term here. This is the 4th term. So if we wanted to find out this common ratio, we could take the 4th term and divide it by the 3rd term, which is this one right here. Lots of arrows going on here. So the 4th term divided by the 3rd term, and that's going to give us r. So it's kind of a a way that we as mathematicians write these things without having to use actual numbers. So that way, once we start getting numbers, when we start talking about specific terms, if we want to take the 4th term or the 5th term or the 7th term, we can always find it just by plugging in that one number. And then we're going to start, everything's just going to start rolling, and it's going to start getting really easy to do. So that's our, that's how we come up with our common ratio. U of n plus 1 divided by n. Well, it's not always going to be about finding the common ratio. Sometimes you're going to have to find other terms within your sequence. So we're going to use our common ratio, and we're going to use that idea, and we're going to come up with a new formula. So let's kind of show this again. We've got our r equaling u of n plus 1 over, or divided by, u of n. All right, so now we need to start coming up with our general equation. So in our general equation, we're going to say u of 1 equals our first term. That's pretty common. That's what we expect. And we're going to say r equals our common ratio. Okay, so if we have those two things defined, if we have those two things set in place, our first term and our common ratio, let's see what we can find. So our first term, well, we already said our first term is u of 1. Our second term, u of 2, is going to be our first term multiplied by our common ratio. So just like before, if we in our previous example, we had our common ratio being 5. So let's just check that out again real quick. We had it being 5. So our second term here, our second term is here. That is our first term multiplied by our common ratio, which was 5, and that gave us 10. So that should make sense. I'm not going to keep on scrolling back and forth, so if you need those numbers, write those down and kind of check as you go along how this works. So you can use actual numbers as well. So u of 3, that's going to be our second term multiplied by the common ratio. Just as we've done before with other types of sequences, well, we can recognize that if u of 2 equals this. So if u of 1 times r, so I can substitute that in for u of 2 there. So what I'm going to do then is I'm going to say u of 3 is the same thing as, let's do it in black so we can keep track of where these things are coming from. This is going to be u of 1 times r, and then times r for this r right there, for that r. So u of 1 times r. And what does that equal? Well, u of 1 times r equals u of 1 times r squared. So u of 3 now, we can say easily, u of 3 equals u of 1 times r squared. All right, you probably know where we're going with this. I'm going to go up over here. U of 4. What is u of 4? U of 4 is going to be u of 3 times r. Whatever that term is, multiplied by our common ratio, we'll get u of 4, our fourth term. But as we saw, just like we did before, this blue one, we'll call that one blue, u of 3 is the same thing as u of 1 times r squared. So we are going to take u of 1 times r squared. We're going to multiply that by our r. So we're just plugging things in here. And we are left with u of 1 times r squared times r. So think back to multiplying powers or multiplying exponents. What do? You add up the exponents, so we're going to end up with r to the third power. So u of 4 equals u of 1 times r to the third power. Now, let's look at the relationships. What is the relationship of this power right here and this term right there? What is the relationship of the unspoken power right here and this term right here? What is the relationship of this power right here and this term right here? Well, it's 1 less. So as we come up with a general formula then, we can say that for geometric sequences, u of n, whatever we're picking, whatever term we're picking, is going to be equal to u of 1 times r and to the power of n minus 1. So whatever we're taking for n, we're going to subtract 1 from that, and that's going to be the exponent for this common ratio. So it kind of cuts down on the amount of calculations we have to do instead of having to punch out every single term up until that nth term. Now, if we have the common ratio and we have the first term, we could easily calculate what the 500th term is. So we can just plug 500 in for our n, and we could calculate away. So, to summarize, if we need to find our common ratio, the thing that is changing our sequence from term to term, that is going to be our r equals u of n plus 1 divided by u of n. If we are looking to find out a specific term within a geometric sequence, then we will have u of n equaling u of 1 times r to the n minus 1 power. That's it for this time, and we'll see you in the next video. All right. Stop the recording. Can't stop the recording. Here we go. Stopping the recording.